Hey guys, we're on day 6 of Unit 10, and we are going to talk about using zeros to find solutions of polynomials. And it says, if asked to find all zeros or remaining zeros of the polynomial, we're going to use long division to divide by a known or given factor. You might be given a 0, but make sure you turn that 0 back into a factor and then log divide. Okay, the quotient will be the other factor of the polynomial. Once we have that other factor of the polynomial, then we can use one of our 3 methods of factoring, completing the square quadratic formula to find the remaining zeros. Okay, so here we go in number 1. Okay, and these problems do take a little bit longer and a lot of space. Okay, so number 1 says, given that x minus 4 is a factor of the function, we need to algebraically find all the zeros. Okay, so because this is a factor, it should go into that polynomial with a remainder of 0. So we'll go ahead and use our long division. And again, some of you might be saying, well, why don't we just factor the polynomial? Well, we can't. If you look at that polynomial, factoring wouldn't work. No greatest common factor, not a D2PS, not a trinomial. And if you factor by grouping, you can try it, but it's not going to work because what's in parentheses is not going to match. So you wouldn't be able to go on. Okay? So factoring can't work, and we can't use quadratic formula. It's not quadratic. And so we're going to go ahead and long divide. And so up at the top, we're going to need a 2x squared. So that the 2x squared times the x is 2x cubed. And then the 2x squared times the negative 4 is a negative 8x squared. We're going to go ahead and put in our subtraction. In 2x cubed minus 2x cubed cancel. And then we have a negative 5x minus a negative 8x, which is negative 5 plus 8, which is a 3x squared. All right, bring down our minus 11x. And we're back up at the top, and we're going to need a positive 3x. So that 3x times that x is 3x squared. And that 3x times the negative 4 is a negative 12x. We're going to go ahead and put up our subtraction. And we will subtract 3x squared minus 3x squared cancel. And we have a negative 11x minus a negative 12x. And so that's really negative 11 plus 12, which is a positive x. Okay, we got one more number to bring down, which is negative 4, and we're back up at the top, and we are going to need a positive 1. So that the 1 times the x is the x, and that the 1 times the negative 4 is the negative 4. We're going to put our subtraction sign out in front, and that is x minus x, which will cancel. And negative 4 minus a negative 4 is really negative 4 plus 4. And so they cancel also, but I'm going to write equals 0. Okay, because I have nothing left to bring down. And so that tells me that that's my remainder. Okay, which means that x minus 4 is a factor. That was true. Okay. And now we're going to go ahead and take this polynomial off to the side. And we're going to use that polynomial as the other factor. So if you think about it, x minus 4 is a factor, and now you found 2x squared plus 3x plus 1 being the other factor, so that if we put them together, we would end up with that polynomial that we started with. Okay, but we don't want to put them together. We want to still continue to take them apart. We already know that this would give us x equals 4. Okay, but we want to find all the zeros, and so that's going to be one of them. But there's going to be 2 more that comes from this one. Okay, and we're going to set this equal to 0. So now that this is quadratic, we could use the quadratic formula. We could also try to factor it. Okay, I'm not quite sure which one will work. I know quadratic formula would always work, but let's try factoring it. It is a hard trinomial. Okay, your multiply is going to be 1 in the back times the 2 in the front, and then our add is 3. So this is our multiply, and this is our add, and 2 and 1 are going to do the job. So this is factorable. So we're going to go ahead and factor it. Again, it's a hard trinomial, so 2x squared. Then I'm going to take the plus 2x, then the plus 1x, and then the plus 1 equal to 0. We'll group the first 2, group the last 2. Out of the first group, we can pull out 2x and be left with x plus 1. Out of the second one, we can pull out positive 1 and left with x plus 1. And so one of my factors is x plus 1, and the other factor is 2x plus 1. And those factors are going to give me my other 2 solutions. Okay, this one's going to be x equals negative 1, And over here, if we subtract 1 and then divide by 2, we got x equals negative 1/2. And there they are. Those are all the zeros. The highest exponent was 3. So we know that having 3 solutions here is a good thing. So we have negative 1/2, negative 1, and 4. Okay. All right. And on to number 2. It says, given that x squared minus 2x minus 3 is a factor of p of x, find all the zeros. All right. So we're going to go ahead and take that x squared minus 2x minus 3 as the factor, and we're going to long divide it into the polynomial, just like we did in the last one. This is a little bit longer though. All right, and here we go. Up at the top, we're going to need x squared, so that the x squared times the x squared is x to the 4th. X squared times negative 2x is negative 2x cubed. And we got to do a third time because we got a trinomial out in front, and that's minus 3x squared. We can go ahead and put up our subtraction sign. And this time we have to use it 3 times. So x to the 4th minus x to the 4th cancel. Negative 4 minus a negative 2. Negative 4 minus a negative 2 is really negative 4 plus 2, which is negative 2x cubed. And we got to do it again. 11 minus a negative 3 is really negative 11 plus 3, which is plus 14x squared. We're going to bring down the next term, which is minus 14x. And back up at the top, we're going to go ahead and need a negative 2x. So that the negative 2x times the x squared is negative 2x cubed. Negative 2x times negative 2x is a positive 4x squared. And negative 2x times negative 3 is a positive 6x. Put up the minus sign. And negative 2x cubed minus a negative 2x cubed is going to cancel. 14 minus 4 is a 10x squared. And negative 14 minus 6 is a negative 20x. We'll bring down our last term, which is negative 30. And back up at the top, we're going to need a 10 plus 10. So that the 10 times the x squared is the 10x squared. That the 10 times the negative 2x is negative 20x. And that the 10 times the negative 3 is negative 30. And we'll put up our minus sign. And 10x squared minus 10x squared cancel. Negative 20x minus a negative 20x cancel. And negative 30 minus a negative 30 also cancels, but I'm going to write 0 because there's no other terms to bring down. And so that's my remainder, which I knew it was going to be because they told me that this was a factor, which means it has to go in a whole number of times, which means there won't be a remainder. Okay. But what I can do now is I can go ahead and take that x squared minus 2x minus 3 as one factor times the x squared minus 2x plus 10 that I got up for the quotient. And if I put those two trinomials back together with a lot of multiplication and distribution, I would end up with this polynomial p of x. Okay, but I don't want to put them back together. I want to take them apart because I want to find the zeros. I want to find out what x equals. Okay, so if we look at this first trinomial, which was the factor, that's actually an easy trinomial. And multiply to negative 3 and add to negative 2 has to be 3 and 1. And the 3 has to be negative in order for the multiply and the add to work. And because it's an easy trinomial, I can go right to the factors of x minus 3 and x plus 1. And therefore, I can also go to the solutions of x equals 3 and x equals negative 1. And now I have 2 out of the 4 zeros, and I know I'm supposed to have 4 because that's the highest exponent. This other binomial or trinomial that we got from the quotient is also an easy trinomial. And so we're going to multiply to 10 and add to negative 2. And the numbers are going to be 5 and 2, but that does not work. The only other numbers are 10 and 1, and that doesn't work either to give me this add of negative 2 at the bottom. I can get a 3. I can't get a negative 2. I can get a negative 3. I can't get a negative 2. So what that tells me is that this isn't factorable. And so I'm going to have to rely on my quadratic formula. So not factorable. Okay. And so plan B is quadratic formula. So we got x equals negative b. plus or minus the square root of b squared minus 4 times a times c all over 2a. And then we end up with x equals, that makes that a positive 2 plus or minus the square root. If we type that in, we're going to end up with negative 36 all divided by 2. And so we got 2 plus or minus, that square root of 36 is not a positive 36. So we're going to need 36 because it's perfect and a negative 1. This is going to turn into 6i. And so now we'll replace that with 6i all over 2. We'll do a little heart pretzel here to reduce. And we end up with x equals 2 divided by 2, which is 1, plus or minus 6i divided by 2, which is 3i. And there is our other two roots for a grand total of 4. So let me just make sure you see what all of them are. But we have x equals 3, x equals negative 1, and now we also have x equals 1 plus 3i, which is a complex root or a non-real root, and 1 minus 3i. And there are our 4 zeros or solutions. All right. All right, guys, I'll see you guys on the back side of notes.